Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have Nicolas here from Lacework. Nicolas, can you please tell us about yourself and the company?
Hi, guys. It's good to meet you. So I'm Field CTO here at Lacework, and I work with our customers and partners to automate their cloud security at Lacework. And if you haven't heard about Lacework, we viewed cloud security through a different prism and one of data. So our goal is really to automate cloud security by adopting a view that security is a data problem, and therefore cloud security is a fairly complex problem. So with data, we're able to provide context for our customers to eliminate risk and to automate their security through a couple of use cases, for example, compliance and posture management, user activity, or what we call behavior analysis. We also look at runtime, so look at container security, workload security, for example, from a protection platform perspective. And we also do vulnerability discovery. And all of this is encompassed in what we call our polygraph data platform. So we have a singular SaaS-based platform. Everything is hosted in the cloud, and we deliver that platform and all the tooling to our customers to really develop faster. So that's really the goal here for our customers, to spend less time on security and more time innovating.
IaaS security, GCP, Azure, and AWS is definitely very important with the digital transformation and everybody moving their instance to the cloud. We are podcast about architecture, so we are very eager to learn more about your architecture and design and how it's working. So please tell us about it.
In order to satisfy small and large customers, we have to do this at very, very large scale. Whether you have 10 workloads in your cloud environment or thousands of workload, it shouldn't matter to a customer what Lacework has. So our what we call a polygraph data platform is front, and I'll go from the front all the way to the back end. So at the front, we have the polygraph UI, which is really the main interface, a single pane of glass that our customers use to get everything from their compliance, their activity, their vulnerability. And that gets ingested into our platform through obviously a front end using APIs. The data ingestion portion of Lacework is very important. We ingest a lot of data because we want to have a high fidelity on security events that happen in our customers' cloud environment. So I'll separate it in a couple sections because we do different things with all that single data platform that is Polygraph. So the first one is agents. So we have a set of agents that run in our customers' workload. And typically what we do is we push metadata into a receiving service that then uses S3 buckets, for example, to store and batch a lot of data before ingesting it into the backend. And I'll get to the backend later because everything ends up in that backend. We also have, for example, cloud-based accounts. So our customers that have AWS, Azure, or Google obviously have cloud accounts, and they may have one, they may have hundreds of accounts. And what we do then is we configure audit logs, for example, it could be CloudTrail, and we do cross-account IAM roles to pull in some of the audit logs directly into our ELT. So we do some extraction and then we load it directly into our backend. Finally, we have our own internal tools. We have APIs. We also have integration directly into third-party tools. So for example, the GitHub Actions for your CICD, your repository, for example, for scanning images, all of that gets pulled into our vulnerability scanner. Again, we plug that into some receiving services and server side, and then we push the results into our backend. Finally, we have what we call the automation portion, so our APIs. So we have a large set of APIs, inbound and outbound, north and southbound, for example, where we can push alerting or integration into ticketing system, notification system, but also inbound for customers that may need to integrate into specific tools like risk management or compliance. At the back end of it, the secret sauce, I think, in a polygraph data platform is really that we're hosted on AWS and our backend is on Snowflake. So we have a very, very large backend that scales pretty much to infinity. We have in the order of petabytes of data that we actually train for our security automation. The good part of that is that the scalability of the platform is not really a thing where we have to invest a lot because our partner in Snowflake really provides that backend for us. So it allows our engineers to really concentrate on automating cloud security. At the front end, we have a lot of APIs. We have Nginx in the front end. We have a lot of services that run for the data platform itself, Polygraph, and then at the back end, it's Snowflake.
It's very interesting how many different features you have on one platform. I'm wondering, in majority of the cases, when we're talking about the cloud security automation for IaaS, we want to understand what you have. So do the discovery, then do the alerting, then do the mitigation. What kind of permission your platform need to be able to do all the things?
I went over a couple types of ingestions that occur. So let's talk, for example, about the audit log, be specific a little bit just for simplicity on AWS, but the same applies for Azure or Google Cloud. So for AWS, for example, we want to access CloudTrail. We create an IAM cross-account role for a customer. And typically we import the single account first, and then we can script to batch import the rest of the AWS accounts that a customer would have. So it's a one and done type thing. And we get that to get all of the cloud resource configurations, for example, and to analyze the CloudTrail event. So we ingest all of that. Now there's a security audit role in AWS. So we latch onto that and we add a couple other audit policy for this. Typically, we have our own IAM policy so that we can get read access to the CloudTrail logs, which is important. And then we use SNS topics and SNS queue to understand when there's new activity to go in. The other types of things, if you have S3 buckets that are encrypted, for example, we need to access to key management just to make sure that we can read those. But typically, we create a trail if it doesn't exist, or we latch onto the existing.
What about GCP and Azure?
In GCP and Azure, it's a slightly different. The aspect here is that for Azure, we want to integrate with the Active Directory as an application. We have the same type of resource groups that we create to store all of our resources that we provision for integration. And then we have a storage account. And then we have, storage queues. And I think the important one is the event grid subscription to understand when new logs come in. And that's in Azure. In Google Cloud, the audit trail log, similar. And then we have a GCP service account that we use to grant access. But through all of this is really understanding that we need the least amount of permission. And we're very, very diligent about that in those types of integrations. The other part is when we run an agent or when we run pipeline integration, for example. The simplest way is really token-based. We get an API token into third-party systems to get read access into GitHub Actions, for example. That's basically it.
I have a question. Do you support hybrid cloud environment as well?
Yes. The idea of Lacework is to provide through the Polygraph, hence the name, the single version of truth across cloud accounts. So when I talk about AWS, Google Cloud product, and Azure, we like to provide the same level of truth and really parity when it comes to compliance, for example, vulnerability discovery, and user activities. So if you think about it, in order to get a compliance from a certain benchmark, you want to be able to say that apples to apples to apples. But the reality is some of the tools that are native or the way the logs are formatted come out a little bit different. So you sort of have to equate different log entities together to get to that level. From an agent perspective, it's the same thing. The agents would run in a Linux environment today. So we support all the distributions across the images from AWS, Azure, and Google Cloud. From an agent perspective, when we talked a little bit earlier about permissions, the Linux permissions or Linux privileges that we can set allows us to run either as root or non-privilege, where the agent starts and then drops its privileges through Linux permissions so that it only runs with the permissions that it needs from a kernel perspective.
Thank you. What we would like to understand is how customer becomes aware of need for CSPM and what is his journey to onboard Lacework platform and start using the Polygraph.
Customers typically will come to the realization that they need to have a sanitized posture, if I can put it that way, through a couple of ways. So one is realizing the shared responsibility model. So very early on, they may refactor or migrate to the cloud, and then they realize that through the cloud provider shared responsibility model, you no longer have a perimeter. You no longer have the same DMZ or the ability to do an application firewall, and everything outside of that firewall is not to be trusted, and everything inside is to be trusted. There's a lot of lateral moves in your cloud environment, and the default policies typically in cloud resources are very open. So customers realizing that very early on. Others through product maturity. So They may over time adopt point solutions. So they see a very specific problem like trust or application monitoring, for example, or compliance monitoring. And then they solve these through individual compartmentalized or incrementalized solutions. And then you start having more and more solutions set. And then you get into an issue where you have diminishing returns, both from having too many tools and having too many employees looking at too many tools, for example, and then correlating and giving the context of these alerts through investigations. So then you start having an increase in time from the detection to the remediation, and then you sort of lose your edge in cloud security. The third one, I think through M&As also. Sometimes small companies get purchased by larger companies and they realize that they don't have a posture, they don't have good security, and then it's driven onto them as well. And lastly, I think customer demand. So some customers of ours do business in certain sectors, whether it's government or with sensitive information. And in order to win new business, they need to start having a better security posture or meet better security compliance benchmarks that they haven't in the past.
I'm wondering, because of amount of data with certain customers, or the amount of different points you're getting, how long will it take you to create a baseline?
Yeah, so you touch on an important topic. So the Lacework polygraph platform learns a user's behavior and baselines the activity within your cloud environment. And in order to do that, what we do is we learn individual workloads and the relationship between these workloads from an API perspective, from an application perspective, from a network perspective. And we build a data model through approaches like unsupervised machine learning to understand the cluster of workloads that are like in their relationship. And that's where, for example, we're able to detect zero-day or unpublished vulnerabilities where there's no disclosure of it, but when exploited, it causes your workload to behave differently. So how do we trust the model, right? So when we first start monitoring users' cloud account, what we do is we build a baseline of those relationships. But that's not to say that we implicitly trust everything. There are what we call known knowns or threat intelligence that you would have in the business. Those could be known bad IPs, for example, or known bad domain lookups, or even known file integrity hashes, right? So we know that this hash of a file is nefarious or malicious and therefore not to be trusted. So we apply both models. We apply what we know to be bad, and then we learn what we know to be good. And from there, we build a model of relationship across all the workloads from a user's account. And over time, I would say hours to days, we baseline very quickly what looks normal in a user environment. And it's not based on scale. It's based entirely on the relationship that workloads may have with each other.
Based on the architecture of Lacework, it's a multi-tenant environment. Assuming that you're collecting very interesting data points in one tenant that can be useful for other tenant, do you leverage this information to make your detection of issues or detection of malicious activity from one tenant to benefit other tenants?
So you mentioned an approach here where we would have a huge data lake and we could train our algorithms based on everyone's data or activity to understand what's normal and what's malicious, for example. And we don't do that. So for us, the baseline of a user account's normal activity is based entirely on their data and not anyone else's. Now, there's one caveat to that I mentioned earlier. Like from a threat intelligence perspective, this is fairly low-hanging fruit, no really computational load for that to build up, to pull a list, for example, of reputation from IP. But when it comes to a behavior analysis, it's actually done on a per account basis. So even from a customer perspective, they may have different accounts, like a prod account or a dev account. They may have feature flags turned on that causes the workloads to behave differently. And for us, that's separate. And in order to be highly accurate, we need to pull in a lot of data. And that's why, for example, when we deploy agents and when we have audit trails turned on, we ingest a very, very large amount of data. I mean, we have multi-petabytes worth of data in our backend. But from a customer perspective, the behavior and the analysis of that behavior is done uniquely on their accounts.
With the amount of different types of features you guys have, I'm wondering, are you currently augmenting solutions? Are you replacing solutions on the market? What is the view here?
So depending on when you learn about Lacework, sometimes it's a bit of a revelation that you realize, oh my God, I have 8 tools when I could have 1. But the reality is we do both. So in green environment where customers are just standing up their configuration compliance, for example, they'll use Lacework from the get-go. More established customers, for example, they have an existing SIM infrastructure where they're logging a lot of data. And they're like spending a lot of time writing rules where a lot of security teams are trying to distribute those incidents response events. What we typically do is we can front end some of these existing products like a SIM, for example, and provide this really, really high signal to noise ratio, really find what I call the needle in a needle stack of what is the actionable alerts or compliance violations, for example, that you need to go fix, provide the right context. And that does two things. First is it really optimizes the security team. And second is it decreases by an order of magnitude the amount of data that you need to ingest for your SIM for compliance, for example, or in a GRC role to have historic logs. The amount of data you're going to ingest is going to be reduced dramatically. And therefore, you simplify your SIM and your security and operations team tooling. So it's a bit of both. Sometimes we replace, often we complement. But overall, we tend to provide a single pane of glass, like you said, across multiple use cases.
Do you use your own product to monitor your own production system for cloud security?
Yes, I think I'd be remiss if I had to mention that we use competitors' product in our own infrastructure, right? But no, we use it. And in fact, it's very useful because we have a lot of accounts ourselves in the Polygraph data platform, and some of our own, for example, red team exercises that we do. Sometimes we try to go around in our own accounts and do things in AWS, and we see it back in our own Polygraph. So it's really a confirmation for us that the product does work. And for me, for example, as a field CTO, it gives me a lot of confidence that I'm not going to have surprises in the field because I do use the product and I do see the reports of the product and it actually works. So yes, we do use our own product.
Many customers struggle between using the native tools from the GCP, Azure, AWS, and using third parties like next-generation firewalls and WAFs. Can your product help with the mix of different native products and third-party products?
Yeah, like I mentioned, for example, CloudTrail. Right? These are the type of products that we work with, and whether it's in AWS or Google Cloud, for example, we had a recent announcement where we've become a partner in the marketplace there as well. So a lot of our customers actually use native tools, and a lot of customers continue to use native tools. What we do is really we give correlation and context and attribution for these tools. So if you look, for example,
like security groups, for example, versus like a firewall.
So what we'll do here, for example, is we'll provide things like least privilege recommendations. We'll look at the users that are being used. We'll look at attribution of VPC flow logs. So instead of hunting for attribution as to which flow log belongs to which workload and which security group allowed the flow to go in, we'll ingest that ourselves. And we're not rules-based. So it eliminates a lot of the rules-based tool that may be native. But our users typically continue to use some of the native tool, but they tend to sometimes decrease the quantity of these tools so as to be more effective.
How does Lacework integrate this popular CICD tool? How do you help to shift left, and how are you checking the information during the deployment?
At Lacework, we're spending a lot of time shifting left, and that means really to integrate security into the DevOps process. So I was mentioning earlier the sources of data that we have and the outbound data that we connect to. So we have proxy scanners and scanners for vulnerability, and we'll integrate, for example, in the GitHub Actions or in Jenkins pipeline, and we'll apply our vulnerability scanning tool directly as a step within your CICD process. And that really helps us identify container vulnerabilities, for example, code dependencies, vulnerability, even non-OS packages, for example. We recently acquired a company called Soluble that really puts us at the forefront in infrastructure as code scanning. So by integrating it into your repo, for example, you can actually scan both the static code analysis in the future, but do infrastructure as code scanning. And then what you can do is you can have an admission controller. So you can decide in your pipeline, I'm going to scan for vulnerability, I'm going to scan for best practices. And that's really the best part of the DevOps process where you want to find this, not so much at runtime. And then with an emission controller, you can decide if I have CVEs that are present in some of the code dependencies that I have, I can stop the build, or I can actually open tickets, for example, for the developer to fix that. And we'll provide the context to do this. So it's very important for us that we can be present as early as possible into the development process, because then the time to fix is really, really quick. Versus if you had to commit it, scanning your images registry, for example, takes a bit longer now to go back into your pipeline process. Or if you don't do that and now you're at runtime and then we find it at runtime, then you have to push it all the way back and then recommit your code, right? So the earliest that we can find it in the CICD process, the better, and we have the tools to do that. And again, all of that gets brought back into our backend as to one data set. So we can actually identify, for example, a compliance violation that may be in your runtime environment in the cloud and figure out where it was introduced in your development process. If something changed, for example, and then give the right context to the developer to go ahead and fix that violation that occurred because we detected a drift in your state.
You mentioned this magic word, compliance. So let's talk about compliance. What do you guys see there? What do you see important? What's less important? And what may be your recommendation to be more mature in the space?
From a compliance perspective, some customers come to us because they are maturing enough that they want to be SOC compliant, for example, or they want to do some ISO compliance. The reality is it's not within the reach of a lot of companies to have a dedicated CISO to do these reports or even to do these audits. And what we provide them, because we have continuous observability, is we can give them a daily report of what their compliances are. If they have violations, then we get really interesting because now we can track what caused the drift, that caused the compliance violation, what security risk it introduced. And that's really what an auditor wants to see. Show me your compliance, show me when you deviated and had a compliance violation, show me how you addressed it, show me your time to resolution and what you did to apply that resolution. And we document all of that, and then we can actually then generate a SOC 2 compliance report on a daily basis or weekly basis or even ad hoc on demand. More importantly, if you have something like GRC, where you have governance, we have risk management, we'll score those. So if you have an exposure or a vulnerability, for example, even let's say a CV that's critical, we'll be able to audit that right away and give you what's your exposure on the network, how many images you may have had, where they were deployed, where they're running or not, and we'll score them. So then you can actually then extract that from either our API or from the report itself and get that into your GRC department and file that. So you can actually now have a compliance tracking.
I want to piggyback on Evgeny's question. When you identify consistencies in compliance, can you mitigate them as well automatically?
Our approach to the compliance violations is to provide all of the context to it. So what caused it, where it deviates, when it happened, to provide what is the remediation to it, to also know where it needs to be remediated. So having some alert channel capability and filtering based on the type of compliance violation to the right team. So it could be your DevOps team, could be your security team, could be your IT shop that needs to fix the drift or the compliance violation. And then what we'll do is we'll provide a lot of context and click through resources, for example, in the report or the email or the Jira ticket, for example, to the actual syntax that needs to be applied in your account to fix the resource that is out of compliance. So while we don't do active blocking, what we'll do is we can actually partner with partners that do this, where we'll provide the actual CVE and then they'll source the actual click button to fix. But what we'll do is we'll provide all the syntax needed to actually fix that very specific resource. So it won't be like a generic fix to be applied, but it will actually have the context of the resource itself that is drifting away from compliance.
This brings us to something that we learned from your website, which is the 5 Ws. Is it a common terminology, or it's something that's related to Lacework platform?
So the 5 Ws is, yeah, you're right. You see that on our website, is the who, what, when, why, and where. And I can actually give you some context to that. It is present on the Polygraph interface. I'm just going to share my browser for you so that you can see it. So here's the intro to what the Polygraph interface looks like, right? So we see our security posture. As I said, you have a lot of ingested data. In over 180 days, we really want to bring a high signal to noise ratio of actionable, critical, or high alerts that we want to have action on. What the event historically would look like here, and I'll just pick one here, which is a log4j. We can go into it. So I have a lot of, we'll see by the color, high and critical events, but I have a moderate one here. And this is where we're presented with the card immediately when we try to click on it to get some detail. So here we see the 5 Ws presented in the event that has a severity of medium. And what we see are the why, who, what, when, and where. So essentially, it's a very benign event, right? We see that simply that there's been an external connection to the objects website of GitHub by a Java process running as a certain IP and under user root in our cloud workloads. So we see that it was root, we see the Java process under what, we see the container where it's located, we see when it occurred, and we see where it went, which is GitHub. In and of itself, looks fairly up on the level, but it's a variation in the behavior in that we've never seen this Java process do that before. So when I try to look down here into the activity, I can see in the polygraph that this is the activity that was flagged. I have a Java process that connected to 3 places, looked up GitHub, the user content, did a DNS lookup as well for the corp LDAP, and then connected to GitHub. Now, is this malicious? Well, it's different. This is why it's red here. It's flagging that this Java process is doing something different. Now, if I then highlight and zoom in on this specific Java process, then I can actually see in the polygraph exactly what it did different. In this example here, we have a Twitter bot, and basically it's a Java process that connects to Twitter, and it has a log4j running. And all of a sudden we see the reason why this was flagged is that not only does it normally connect to Twitter, but now it connected to these 2 DNS lookup. It went on GitHub. It actually also looked up Bitcoin or miner, right, XMRing for a cryptocurrency miner. So we know that this is completely abnormal. And now I see exactly what the activity
Can I see how much money generated? No?
Hopefully, well, if you're able to infer the CPU usage that this process caused, then you may be able to calculate how much money you're making here. But, obviously this has been compromised, right? Now I can see, like, imagine this is pre-CVE of log4shell, for example. I have no name associated with this right now. It's December 1. The CV has not been published. And I'm looking at this. I'm saying, okay, well, I have a Bitcoin miner that is actually within a Java service, which is not normal. And I can see what's running here, that I have a Java process running. If I look back at my event here, I see that it's actually running log4j. So now it's pre-0 day. It's an unpublished critical vulnerability. But I see right away, because the behavior of the Java binary changed, because it went and looked up a different host name, because it connected to an external website, this is being flagged. Now, immediately I want to know, where is this present? Which containers run this? And I can find here all my container IDs and when they were started to run this type of behavior. Now, I can also look at my exposure and see, how many containers do I have that have this actual binary present? And I can find now and really look at, now I have my vulnerability post CVE announcement, and I can see where they are and where I can fix them. So now I have a list of priority available to me, and it all started with a very innocuous behavior. A Java process looked up a different host name. And immediately what I was given is enough context to the who, what, when, why, and where, as you were asking, to really get to the bottom of the investigation and really accelerate my remediation.
Given that you're integrating in the DevOps process and you know the software composition analysis of most of the build artifacts, would it be possible for me to say, hey, I want to know where I have log4j of version 2.14.1 running?
For example, when the log4shell vulnerability came out, a lot of people spent a very long weekend trying to audit their cloud accounts and see, first of all, do I have log4j? Is it installed as its own package? Is it installed as part of a third-party software installation? Do I have it in my images, and what images are they running? Are they exposed if they're running? And yes, sir, we have multiple sources of data. So we have file integrity management. If I know the hash of the jar file for log4j per version, I can find it, whether it's attached as an OS package, as a package dependency with a third-party software, or, for example, just running as a process. And then I can actually then find through my proc table as an agent, for example, where it is running on my network or where it's just on the file system. So there's a differentiation here. I have a log4j, but it's not running or it's not exposed, versus if I have a log4j that's actively exposed in my cloud accounts. The second one is where in my images. I may have a lot of images, container images that have log4j, which ones are actually deployed and which ones are not. And then finally, where in my code base am I actually including dependencies for Log4j? So at any given step from runtime all the way down to build time, the ability to understand your exposure to Log4j is really critical, for example, from a compliance perspective, but also from a remediation perspective, understanding where do you go first to remediate? Where do you start? And that's where threat assessment and scoring of that vulnerability. So Log4j in and of itself came out as critical, but if you all of a sudden you have 894 instances of Log4j in your network, you need to know with the limited resources that you have, where to go and act first to remediate. And we'll give you that ranking based on the exposure that you have on your network, in your registry, and in your code base.
So Nick, I have a question about cyber insurance. We know that premiums are skyrocketing during the last year and the attack surging. How do you think CSPM solutions can help customers to lower their premiums?
Yeah, so CSPM or security posture management is really the first thing to do. And if you don't have that, you're not really closing your doors and closing your windows at night, and anybody can get in. So if you don't know what's going on in your network, then your risk goes up, and I would imagine your premiums may go up as well. So an auditor will want to see that you're applying best practices from a security configuration perspective, that you understand the security risk that you may have across all of your cloud accounts. And CSPM is really the first step to securing your cloud accounts. From there, understanding from an audit perspective, having continuous observability, what is your compliance to different security benchmarks, how often you actually monitor for that compliance. Because if you only do a yearly check and then you have your report on a shelf, it doesn't really help when someone comes into your network and then they exfiltrate all the data, for example, and start stealing your intellectual property. So having a continuous observability of what your compliance is checks the box from a risk assessment perspective, and then continuously hunting for vulnerabilities, for example, in your runtime, then adds layers of security to your security posture. So it's not just about being compliant, doing your audit, having your books in order on a yearly basis. We've gone too long just doing that, and it doesn't really help when we have a breach, for example, that we were compliant 6 months ago, so we should be okay today. So from a risk assessment perspective, that's going to start becoming more thorough to understand in real time, what is your compliance today, right now, show me when you deviated, when you had a violation, and show me how you remediated it. I think it is going to help keep those breach costs lower from an insurance perspective, for example.
Nick, thank you very much for your time today. We definitely learned a lot about you, about the technology and what you guys do and how you guys contribute to cybersecurity.
Thank you.
Thank you, Nick.
Please remember to subscribe to our podcast and join us for our next episode.